All right, lesson 5-5. We're going to be talking about inequalities that involve absolute value. All right, and as you'll remember, absolute value definition is the distance from zero. And we've talked about equations with absolute value, and now we're going to talk about inequalities that are less than and inequalities that are greater than. And it really is going to be talking about an inequality that the distance from zero is less than something. So companies use absolute value inequalities to control the quality of their product, this little thing tells us. Do you know to make baby carrots, they actually make long carrots and slice them into 3-inch sections and then they peel them? Yep, sure enough. So they maintain some accuracy within 1/8 of an inch, so it can be between 2 and 7/8 and 3 and 1/8 inch. Something like that would involve using the absolute value of an inequality. All right, absolute value of inequalities. The inequality x is less than 3 means that the distance between x and 0 is less than 3. All right, so the absolute value of x means that the distance from 0 is going to be less than 3. So that means it's going to be between 3 and -3. So you would write, so we know that x is going to be greater than -3 and x is going to be less than 3. So the solution set would look like this. The absolute value, excuse me, not the absolute value, excuse me, x such that -3 is less than x and it's also less than 3. When solving absolute value inequalities, you have two cases, okay? The first case is going to express the non-negative value symbol of it, or value, absolute value of it. And the second case is going to express the negative value. So we're going to set it up twice, very similarly to how we did it for absolute values dealing with equation. Now the solution to an absolute value inequality is going to be the intersection of the solutions of the two cases that we're going to look at. Okay, let's see what this means in a real life problem. Solve each inequality, then graph the solution set. Okay, so here we have the absolute value of m plus 2 is less than 11. All right, we're going to have to write, case 1 and case 2, right? So we're going to say m plus 2 is less than 11. And we're going to say negative m plus 2 is less than 11. So we have both the non-negative and the negative cases for this inequality. All right? So here, well, let's just solve this side. We subtract 2 from both sides, and we find out that m is less than 9. Now, remember, this is like having -1 out here, right? So it's negative m minus 2 is less than 11. Now, I want to get rid of that negative m, right? So I'm going to multiply everything in the inequality by -1 to change all the signs. And I will get m plus 2 is less than -11. Let me get rid of this screen recording box, please, or at least slide it someplace else. Okay, so what we would do, minus 2 on both sides, and we'd find that m is less than -13. All right, so that means, see if I can blow this up a little bit for you, that m is less than 9 and m is greater than -13. Oops, what did I do wrong? I know what I did wrong. Anybody see my mistake? When I multiplied by -1, I had to flip my sign. So m is greater than -13. I beg your pardon, guys, missed that. M is greater than -13. Okay, so the solution is m is less than 9 and m is greater than -13. And you would write that as set the solution set such that m is negative 13 is less than m and is less than 9. And this is what it graphs like. Okay, so it's all the numbers between negative 13 right here and positive 9. It does not include those numbers, but it's the numbers in between there. Let's look at another one. Absolute value of y minus 1 is less than negative 2. Y minus 1 cannot be negative. So it is not possible for y minus 1 to be less than 2, right? So there is no solution, and the set would be considered empty. Let's look at, here's a couple practice problems for you. Stop. Okay, try these, and we'll look at them tomorrow. Or actually not tomorrow. This is Friday, so we will look at them on Monday. I am going to give you a word problem. I'm not going to hold you responsible for them except in a bonus situation. But I just want you to look at how we use these things, because I think it's important to understand the value of studying them if you understand where you might use them. So here we have a recent survey showed that 65% of young adults watch online video clips, okay? 65%. The margin of error was 3 percentage points. Find the range of young adults who use video sharing sites. Okay, so we have we have case 1, which will be non-negative, and case 2, which will be negative. So we'll have x minus 65 is less than or equal to 3. Right? Because the difference is less than or equal to 3, to those 3 percentage points. And we'll have x minus 65 is also the negative of that, right, is less than or equal to 3. So if we solve for that, we find that plus 65 on both sides. And we find out that x is less than or equal to 68. And we rewrite this equation as if we're multiplying everything, and we find that by, negative x plus 65 is less than or equal, oops, we've got to flip it because I'm multiplying by negative, right, is greater than or equal to negative 3. Or we turn that all around by multiplying by negative 1, and we get x minus 65 is greater than or equal to negative 3. So negative 65, or add 65 on both sides, sorry. And we find out that x is greater than or equal to 65, and a negative 3 is 62. Okay, so the range of adults who share video games, see if I can get this to move, is going to be x such that 62 is less than or equal to x, and x is, and x is also less than or equal to 68. All right, it's someplace in between there. This is an x. Sorry, guys. Okay. Now, I did add a guided practice problem of one of these, but again, notice it's a bonus. If you get it right, you can add it to your homework grade. If you choose not to do it, that's fine. Okay, the other thing we want to talk about is solving inequalities that are greater than, okay? The inequality x is greater than 3 means that the distance between x and 0 is greater than 3. Okay, so that means that it's going to be greater here or greater here. All right, so the solution set for that would be x such that x is less than negative 3, and here it's going to be an or x is greater than 3. All right, so if you think about it, it's either going to be this or it's going to be that. So it's this type of inequality that says the absolute value of x is greater than is going to be an or set notation. Let's look at a problem here. Okay, so as with the previous case, we're going to have a non-negative and a negative solution to this. So here we have 3n plus 6 as our non-negative solution. All right, so we have 3n plus 6 is greater than or equal to 12, and we're going to have negative 3n plus 6 is greater than or equal to 12. Okay, so you'll subtract minus 6 from both sides. 3n is greater than or equal to 6. Divide both sides by 3. We're dividing by a positive, so we don't have to change any signs. N is greater than or equal to 6 over 3 is the same as 2. Now over on this side, we'll flip this thing around, and I'm going to skip a couple of those steps this time. And we're just going to write this as 3n plus 6, flip the sign, is greater than or equal to negative 12. All right? Everybody follow me? I skipped a couple of those explanation steps that because I think if you just realize when you set this problem up first, you just take that and move that over to there, and you're in good shape, okay? So now we're going to minus 6 on both sides, and we get 3n and you have to flip the sign, of course, is less than or equal to negative 18. We're going to divide by 3 on both sides, and we find that n is less than or equal to negative 15. Okay, so the solution set here is n. Let's see if I can extend my page. So the solution set here, let me enlarge this so we can see it a little better, is n is going to be less than, n is going to be greater than or equal to 2, and n is going to be less than or equal to negative 15. What did I do? Oh, divide by 3, my bad. Gosh, can you tell I'm doing this after the dance? Yes. You can. How about negative 18 divided by 3 is negative 6? That's a little better. Glad to see some of you guys at the dance. Cameron, Kyra, Eve, Mackenzie, Catherine. Let's see. There must have been some other. Bassett was there. Anyway, there weren't many 8th graders, and we did miss you. It just wasn't quite as festive without you, but I know you all had other things to do. Anyway. So the solution set for this is n such that n is greater than 2 or n is less than or equal to negative 6. So these are your or situations. All right, here's your 2 guided practice problems, 3A and 3B. Good luck with these, and we'll do them on Monday. And maybe on Monday, too, you should come in with one idea for student council to sponsor a different kind of event. So if you guys don't like coming to the dances or think they're too boring or too whatever, what would be a fun thing for student council to sponsor for 8th graders or for middle school that 8th graders would enjoy more? So think about that and submit your ideas on a note card to give to me on Monday. Thanks, guys. Have a great weekend.